Hello and welcome to another video. Today we have something very different on our bench. We have two stream decks from Elgato on our bench. And I got these as faulty because I want to fix these and actually use them for my streams. Or like for my videos in general. Because currently I'm using just OBS with a mouse to click through things. And I want to have at least one of these working. So these two came with two different faults. So this one is supposedly working, but has a broken cable. As you can see, someone tried to do something here already. And this one failed during a firmware update. So what I'm planning is taking the firmware from here, dump it to be able to put it onto there, and also just replace the USB on this. I have no idea how these work. I don't know how to work on them, what they're supposed to do, or like, yeah, I know what they do at the end, but like, I have not seen a video about how someone fixed these or did anything to these, so we're just going to find this out together. So let's see for this one, because this presumably is open. So the faceplate comes off. It seems to be glued. Let's see, does this just fall out of its case now? Or how do we... Because I cannot see any screws or anything. Let's see if we can pry this out of here now. Okay, we can. So we can pry this out. And this is just a cable, okay. But the cable seems very fixed there. Okay, so what do I see? I don't see a lot. I see a Nuvoton chip, a linear regulator, one, maybe two linear regulators, and a BIOS chip. Okay, that's, I think, all there is to this. So let's then, I'm gonna show you that under the microscope. So let's see here together. We have the incoming USB. We have 5 volts there. Then we have ground there. Is there double ground? Interesting. There might be shielding. Oh no, this is both the same. We can see when we look at this, both of these grounds are connected. They're on the same plane, pretty surely. Man, this soldering job from these cables looks awful. Holy moly. Like, no wonder these fail. Like, look at this. Like, this isn't the one that has the bad USB cable, but holy moly, yeah, I can see why that can happen. Let's remove this hot glue here. So, this is a linear regulator, and I think this is like, yeah, 3.3 volts. This just takes 5 volts and makes 3.3 volts out of it. Then there's another regulator right here, and I think this is a 1.8 one if I'm not mistaken. And there's then the EEPROM and the actual main controller. A Nuvoton chip. Yeah, and so far nothing much more. Some passive components around here. A jumper. A con maybe for programming or something. More stuff here. But I don't even think that there's anything going to be on the backside, because the backside pretty surely only has the display and that's it. I think this is all we have. So nothing much to fix. Let's first things first. This isn't the one that has the problems with the cable, but we preventively are going to be resoldering all of these cables, because this soldering job is awful, man. Like, there's not enough solder added. So let's see here together. Oh yeah, these remove so easily. Man, what is this cable that they're using? Like, really cheap cable even. Damn. Because these things are not cheap. Yeah, let's not short any of this. Man, this is awful. Like, the cable that they're using, not great. Like, no wonder some of these fail with, like, broken cables, because this cable really doesn't seem very high quality. Like with the amount of conductors, I mean there isn't much current going through these. So yeah, it's a cost cutting measure, but still. Okay. So now we are connected. I don't like how these two look, to be perfectly honest, but I don't think that it's going to get any, like, much better than what it is currently. So we're going to leave it at that for these ones. We might insulate them or fix them down in some way so they cannot short to each other. Because especially like these ones, these strands here are not good. So I got some of those strands off. But okay, so far, I don't think we're going to continue with this one. Because what we need is the firmware on here. And for that, we need the other one. Because the other one is definitely working. And we want this firmware. So let's put this one to the side. Let's go to the overhead. And see what it takes to open one of these up. So this faceplate is supposed to come off. But I'm not sure how. It's probably just glue around the top side, because you can see this copper tape. And I think it's mostly just that. So let's heat up at the top there. We're just going to go for 100 degrees, very low airflow. And let's see if we can heat this up here and get this get this separated. I'm really scared of like destroying these beautiful panels here. So I want to move quick with the heat. I might want to pour some alcohol into there also, in order to open that up. Okay, enough heating. Let me get a prying tool. So, let's see. Let's get this open. Oh yeah, okay, this opened really easy. We might not even have needed heat. Yeah, this just opened up quick. Oh, this thing is completely different. No way. Wow. This thing is completely different. Like from the ground up, it is, oh, based on something else. Oh, that sucks. Let's go to the microscope. So let's see here. How can these be so different? I didn't expect that. So this uses an Atmel chip. Then this is video RAM. And this is flash. Is there... I cannot see an EEPROM. There doesn't seem to be a dedicated EEPROM on this. It's probably just stored in the flash. Man, that sucks. So this is the one that has the bad cable. So we will have to test for that. Okay, let's see right here. Let's try to remove this hot glue. And the soldering job. This one looks partially better, except for that one. This one is very weak. But like these two, for example, look a lot better here. Not great, but better. But this one is bad. So let's do some resoldering here. And there we are. Now this is also soldered. And on this one, this was the unit that had the bad USB connection. So we now are going to test this cable with continuity to the USB port. So let's see then. Let's get the other end of this port. Let me see if we can get a capture of this. So let's see. So this is the USB port. It looks fine. Let me see if I can get that clamped down somehow, so that we can actually probe around in here. So this is quite difficult to film. So we either have the USB port in focus or the Stream Deck. So let's see. 5 volts. Should be one of the outer ones. 5 volts, it has continuity. Then data. And I'm not getting anything on data. This one is this has continuity. So that one is supposed to be here, but we don't have that. And ground is there. So what we have is that this one is broken somewhere. This cable, this is either data plus or data minus, one of the two, has a bad connection. So let's check at that one point where there's glue. Like right here, there was tape or glue around here already. Let's see. Is there anything broken here? No, I don't think so. No, this was just a marking for something else. So big problem now is, how do we know where to cut the cable? Like, where's the break? Let's see if you can see something here. There's nothing obvious broken here. One of the most common places, obviously, is where the relief is. Let's get this out of here. Can I get this out of here is the question. But I cannot see a break anywhere. And it's not like... Oh, can I even get this out of here? Okay, big question now is how we're going to do this. Are we going to do it the jank way and just run a wire somehow? Or are we trying to do something properly here? So, because I'm going to be using this myself, we're going to be doing this a little bit jankily. What I want to try is I want to cut some part of it open. Like take half of the length, for example, and cut it open and try if that white wire has connection to here or not. I would suspect that pretty much the break is somewhere close to the housing, but I want to make sure of that. I want to try it out. So let's take a knife. Where is my scalpel? There it is. So let's get this into focus that we can see. Let's try to get some of this insulation out of here. Okay, so what we can see right here, we can see this is an insulated cable. So the stranded wires that we can see right here is just shielding, and there we can get to the actual cables. Let's cut this out of here. So let's see. More shielding, and we want to get to this wire right here. So let's clip this off a little bit, clean this up. So I think I will be able to pierce this white wire, and let's see if we have continuity to it here. So we get one probe right here, and let's try if I can pierce this. And we have continuity to here. That is interesting. So up to there, it's definitely good. So that is quite some length of cable where it's good. So I think we can close this up again, because I don't need anything out of here anymore, because the cable was up to there good, I think. Or let's not close it up, so we still can check that. So where else could the break be? I would then think that the break is probably close to the USB cable itself. Let's see. I just saw there's another one of these strings here, or like tape. So also here, nothing to see. So my suspicion is that we have a break somewhere there. And the easiest would be to cut this off and get a different ending on here. We're going to do that. Let's cut this somewhere here, for example. So I'm going to leave a little bit. Let's cut this and let me uninsulate some of this wire. So right now we see the outer shielding, which is connected to ground. We see this also, all the shielding. So let's open this up And now we can see our 4 wires that we need. Now I'm very interested. Let me take isolation out of the white one. And now let's see. So let's get this in focus. So now we can see the end of the wire and the part inside the deck. So let's see if the break was actually if the break was inside the port or not. And it was. Yeah. Okay, let's check the other wires as well. But currently it looks good that we found where the break was. So the break was very close to the USB port itself. So we still cannot get both in focus, but let's see. So red has continuity, white has continuity, then green has continuity, and black has continuity. That is very good. So all we need is a new USB port. Let me see if I have one to solder onto here. So let's prepare the wire here together. So what I like to do is I like to twist these together as far as I can. So these two are going to be connected anyways. So let's see here. Let's put some solder on all of these. So there's really very little heat needed here because this is so thin wire that they use for this. And what I'm doing here is I'm connecting the black and the shielding, which theoretically isn't right, but at the end is the same. Because as we were able to see on the board as well, they are just connected. They are just connected to the same plane anyways. So this is the cable that we're going to in length. So I first thought about lengthening this cable, and I've already prepared this here in order to lengthen it. But I remembered I actually have USB ports here. Like, it's not completely good. Like, this that you can see here usually is being used to put on a board. Like, this is a vertical mounted USB port that you can use. But in our case, we are making a cable out of that. So I will be soldering the cable onto it, onto the places where it needs to go. And then I am going to put hot glue around it. And we are going to make a cable like that. Like, I know they sell like these proper cases for them, where you can put them in and then just screw together. But we're not going to do that because this is for myself, like I said before. Like, this will be totally fine. And I didn't reference now the manual or like the USB specification, but I think what I'm doing currently is correct. The next one should be the white one, then the green one, and then ground. So let's see, can I put you onto here? So this is how I remembered it. That we had first red, then white, then green, then black, and then the outer sheathing one. And let me quickly reference that online if that is correct. So I had a look online, and this should be correct, like I did. So we have 5 volts, data minus, data plus, ground, and then the shielding. And you can see from this side. So what I'm going to do is I'm going to be adding a lot of hot glue to this to have something to grab onto here and then actually plug in. So yeah, so let me do that, and when I'm done with that, I will get you back into here. And also the hot glue will act as an insulation between those points. Like you can see that it looks like it's quite close here with some strands. Like these two can touch, these two don't matter. but like in between these, we don't want anything touching, and there isn't. So yeah, let me put some hot glue onto here so we have something to grab onto. So here's our botch job. We could use a little bit more hot glue right here maybe, but yeah, and maybe like that to insulate that. But it's working well, and you can grab it well. We will have to test this now. I need to get the firmware for this, and then, or like the software on the PC, and then let's see if this works. So I have absolutely no idea how this works now. Let's plug this in and see. Will it be recognized? It is being recognized. There it is. Okay. Is there like a profile stored? Next page, multimedia. This is muting, tutorials, show desktop. Okay, does this work if I press this? It does work, okay. So yeah, does this mute my audio? It does mute all of my audio, you can see at the bottom. Very nice, and this now works flawlessly. Very, very cool. So I'm wiggling the wire and it's not stopping. Everything works. And oh, this can even support multiple pages. Oh, you can switch between different pages then even, and like double your inputs. That's crazy. Okay, because now I'm pushing the buttons on the Stream Deck and that is working. Very interesting. Okay, so one is fixed. One is working now like it should. Let's get to the other one and try a little bit of things out there. So, back at this one that we haven't fixed yet, that is supposedly having a firmware issue. Let's see right here if we can pin out this USB as well and try it out. So, like I said, only one thing in focus at a time. But let's see if everything is continuous here. So let's see, the 5 volts has continuity. The data minus has continuity, data plus, and then the ground. So, okay. So the cable is not at fault here. Let's plug this in and check for some voltages. Can I plug this into a 5 volts? Do I have anything to plug this in? I don't think. So right now we see 120 milliamps of power consumption. So let's check for some voltages before we do like any software part, because yeah, one thing is what the customer says and the other thing is what actually happens. So let's see, from here to here, do we get 5 volts? We do have 5 volts. Okay, what do we have here? We have also 5 volts. Let's see right here. Is this supposed to be, yeah, 3.3 volts. So we do have 3.3 volts. We have 5 volts right here. This should be 0. Then this is one. This has data and this has data on it. Like these can go bad as well. I've seen that before. And let's then check on these caps here. So what does this have? Also 5 volts. So this is ground, I think. And let's check here. No, this is the feedbacking. So what is this? This is also an input. Then let's check here. 1.8 volts also present. Okay. So the 1.8 volts is probably then going here. 3.3 volts, okay. And here, also 3.3 volts. So this works on 3.3 volts. This is also 3.3 volts. So this is also a 3.3 volts regulator. Interesting. So yeah, it really seems like this is a software issue on this one, because it seems to be running and nothing is getting like hot or anything, but we don't have anything on the display because there's not much voltages. So there's that voltage, that one coming from there, this one, and then the 5 volt incoming. And let's unplug this. And one test that we can do is for the data lines that they reach. So what we can do, we go on one of these data lines and it should be coming up right there. And then from this, it should be coming up right there. It does. And then from this one, it should be the one next to it. Let's see. To there, to here, and from here, it should go to there. Okay, so the data lines also are continuous from the cable to the controller. So I think I have to somehow get a dump for this chip. So let's get to the PC, connect this up. This is a 3.3 volts chip like we saw, and see if we can get any data from it. So I will be trying to get a clamp onto there now, and let's see if my programmer can recognize this EEPROM. Let's put 3.3 volts. And I cannot currently. And there we are. It actually recognized the chip. Why doesn't it take the chip? Okay, it recognized XT25F32F. 4 megabytes chip. A 32 megabit chip. So, yeah, let's put that into here. We need an XT. So it doesn't appear to be that I can actually read out this chip. That is crazy. I have not had this happen before. Wow, okay. Let me see if I can read this with a different chip that also uses, if I just put 3 volts onto there. Let's see. I think I can read the chip, but this is interesting. So the chip itself isn't supported. I just took another configuration now. Let's see if I can read this chip or not. If there's actually going to be any content in here now. So the chip read, but it's completely empty. Not too sure if that worked. I also don't really know how to approach this, because I never had it that a chip wasn't supported like that. Let me figure something out here. So, it's been some time, but I did what every sane person would do, and I went ahead and bought another one. So, to recap, this one I've been using since quite some time now. This is the one that had the broken USB cable, where we just had to resolder a plug. Then we have this one that has bad firmware on that chip, but these two are different versions from each other. And I went ahead, bought a working one. Hopefully, that this is the same version as this one. I went ahead and compared the model numbers, and they should be the same. We are hoping that these internals match these internals, so that we can read off whatever's written in that chip. So let me turn this one off, and let's see if I can take the firmware off of this one. I got way too deep into this, but I got to say, the firmware for this one, or for that version, was just nowhere to be found. Like, nothing at all. So that's why I just thought to myself, I'm going to bite the bullet, and I'm going to put that out there. So let me grab a tool to open this up. I've had a look around, and there are people that talked about that they had a similar problem with the problem with the firmware, and that someone presumably has this bin file that needs to be on here, but there was just nothing openly available, and I want to change that. Yes, it's the same. Thank God. That's so good. Now we can see these internals are the same ones. They both use the Nuvoton chip. The PCB is a little bit darker green than the other one. Let's zoom down together here. But this should be fine. Let's check. Is the Nuvoton chip? I think that's the same chip. Like, yeah, it's completely the same. So, let's go ahead. Let's read this chip out. I'm going to start to try to read this out with just a clamp. So I'm going to use a clamp that I usually use for BIOS chips, put that on here. Let's see. Let's see together what kind of chip this is. Let's go to the microscope. So we can see this is the chip that we need. Let's angle this so that we can actually read what is written on here. So here we can see it clearly. An XT25F32BS. So pin 1 marked at the top left. Let me get a clamp and let's see if I can read this chip out. So let's see here. This is a 3.3 volt chip. Let's see. It does recognize the chip, but it doesn't auto pick the whatever is on here. Interesting. Usually this works in a way where it just recognizes the chip and then picks the exact option for it. So I picked a chip that has the same size and is a 3.3 volt chip. Let's try to read this now. And we seem to get content. Okay, I'm not sure if this worked correctly, but I'm going to save this. So this is the dump of the working one. Let's put this one to the side and let's get the not working one. So let's try to read this. So this is the non-working one. And the content looks very, very similar. Okay, let's save this as well as the not working one. And let's now flash the working dump that we had onto this one. Very interesting. You can see there's very high current, like there was 70 milliamps. Like for flashing a BIOS, that's high current. That means that the whole device is probably powered by that 3.3 volts. So it's programmed and verified. I guess let's go over to the bench and see if it turns on then. So big moment of truth. I know I'm not in frame because I have to plug this USB in. And let's see if this works now. Oh, it's working. Nice. That is so good. That was all that it needed. Oh, let's get the money shot now with 3 of them. Oh, these are so... Oh, I'm so happy that that worked out. So very interesting currently. This one isn't initialized. So you can see that it's on, but it's not being initialized. I think this might be a conflict of the serial numbers now, because one of them carries the serial number of the other one. So let me see if I unplug this one, if this one starts working. Yep, and that's exactly what happened. If both are plugged in, they are not working. Okay, do we reassemble already? Do I look? Let me see. I'm going to compare the dumps that I had, and I want to see if I can see something that resembles a serial number. If maybe we can change that by ourselves and then write that into there. 1 second. I cannot believe it. I actually got it working. As you can see, all 3 are working now. What a beautiful picture of all 3 working. And let me show you how I did it. So I was correct in the assumption that one of these took the serial number of the other one, and then the Elgato firmware didn't recognize these. And it only could recognize one, and the other one, while it was also plugged in, it couldn't identify it because it tried to register itself with the same serial number. So these things, I really like them, but I hate that they are so software dependent. Like without the Elgato app, they don't work well. Or they don't really work at all as far as I know. Maybe there's some other project that can utilize this. But yeah, they are really bound to the software of Elgato, which is difficult. But yeah, now both are working. Let me show you what I've done in order to get this working. So, this is the dump of one of them. And what I've done is I first tried to do this with ChatGPT because AI is really good, or large language models is really good with high amounts of data. And I told it to search for the string of the serial number that is written in the Elgato software. I can show you that. Right here, there's a string with the serial number. And I let it search that. And in general, let it search basically all of it. But it couldn't find anything. There's some plain text, like there's in config RTC, start, SPI loader, and so on and so forth. There's some plain text here, but the serial number was nowhere to be found. And I also told it to use like conversions, like hex conversions, base 64, I think it's conversions, and so on and so forth. And it couldn't find the block where the serial number is. There's nothing where it's obviously that there is a serial number here. But what I did then is I went through the data and just looked for specific blocks. And the interesting thing is that most of it is empty. The beginning has quite something. Then most of it is empty. And then there's a single block in between. And then there's nothing again, as you can see. Nothing, nothing, nothing. And then a single block starting. Oh, it's so hard to get this. But this block right here. Let's see, where does it start? Right here. It's starting at, what is this? 00102FF0. Somewhere here. And then I took all of what is in this block and I replaced it. So you can see there's this random block in between here. And then there's only data at the beginning again. So what I did is I merged both files. So there's these two files. One of the with the working, not working. I took the block out of the not working one, put it into the working one, and then flashed it, which is this file. And all of a sudden, it started working. There's also the from where to where it replaced the block. So from, oh, I just said it wrong. It did it here from 006 FFF0 to 00073 FFF. And this worked, and all of a sudden we have all three working. I will provide these. Like all three files I will be providing for people in order if they want that. Because I don't care if you have the serial number of my Elgato Stream Decks. Really don't care. Because we're not going to be using them on the same PC. So yeah. So that people in the future, if they have ever a problem with the with updating this exact version, then I will provide these ones. So we got all three working. I'm very happy for this. This escalated quite quickly with now having three of these. I originally just wanted one for myself, but this is sometimes how you end up. But one thing I got to do is all of these, the glue isn't sticking to them anymore properly. So the glue is like, it looks like a copper strip like this one, and it just doesn't hold on any of them anymore. And I will just have to reapply like double-sided sticky tape to these, and then it will be done. But yeah, this is it. Thank you very much for watching. All of my tools are linked in the video description as always. This was MainboardMedic. I hope you enjoyed this video and learned something. Thank you very much, and goodbye.